Hi, I'm Dr. K. Rajendra Prasad. I'm working as professor and head for the departments of CAC Data Science and CAC Cybersecurity. Today my topic is on derivations, parse trees. First we have to discuss what is the derivation idea is. So derivation is very important from the context-free grammar point of view, because the context-free grammar, nothing but it has so many number of variables, terminals, productions, and with the starting symbol. It is the basic idea of context-free grammar. Now, with the help of the production, when starting from any starting symbol, finally we can derive what the string. That is important. That case we discuss with derivations. Means you want to validate any particular string, or you want to validate any language string. That case you take the basic idea of derivation. So here the derivation is a basic sequence of production rules in order to get the input string. Means here the idea of a derivation is you can make use of some productions which are given in the context-free grammar. From the context-free grammar, you take some sequence of production rules. You can decide what sequence on what sequence you are applying the rules so that you are getting the your required string. So that is the idea of derivation. Here, the in the derivation, you obtain the string is using a single derivation or multiple derivation. Single derivation, we can make use of the symbol is implies. In the case of multiple derivation, you make use of the symbol is asterisk, which is equivalent to you can apply the single derivation is multiple times. Means, for example, I am taking this is a derivation here derive some string. Again, you can apply another rule. Can get one more time. That string is you are getting this is the idea. Means you are applying the derivation is multiple times. The derivations, multiple derivations you are going to apply. Multiple derivations you are going to apply. At that time, you make use of the particular symbol is the derivation symbol, and also you can must define the asterisk. Means in the derivation you can make use of what type of derivation, nothing but maybe for single derivation. This idea is called as single derivation, or you can make use of some multiple derivation, because sometimes you are getting your required string is with the help of the single derivation only. Sometimes it is not possible to get your required string within the single step. You can make use of multiple steps. Means you can apply the derivation is multiple times. At each derivation, maybe applying the production is may be same, it may not be different. So finally, your concluding is you can make use of basically a single production that can be denoted by symbol is like this. Multiple derivation, you are applying rules. Production rules are multiple rules, or same rule that can be applied multiple times. That can be denoted. The symbol is implies and the asterisk. It is called as we are applying the multiple derivation. This idea is called as a single derivation. That is we have to discuss in the derivation point of view. A derivation is basically a sequence of production of rules. Means here deciding very important thing is on what order you are to apply the productions, so that whether you are getting the string or not, your required string or not, that's a different issue. So for obtaining some resulting string, we should show some derivations on what we are to getting the expected string is. in what sequence of production rules you are getting your respective string is. That is we have discussed in the derivation. So here two types of derivations we have to discuss. One is called as leftmost derivation. Another one is rightmost derivation. So what is the leftmost derivation is? We always substituting the non-terminal. You should describe the position of non-terminal is always left side. Means at every time of derivation, we should replace the string at what side nothing but leftmost non-terminal only. Hence, it is called as leftmost derivation. Or simply, you can go for the replacement of the strings at every step of the derivation. That should be done in the direction is from left to right. From left to right. That is called as leftmost derivation. Another is rightmost derivation. What do you mean of rightmost derivation is here replacement of the string that can be applied at rightmost variable. That's called as rightmost derivation. So in the case of rightmost derivation, generally the process of replacement of the strings that can be applied, the direction is from right to left. So in this way, so we have to getting the idea of leftmost derivation as well as rightmost derivation. So next one is a sentential form. What do you mean of sentential form? It's very important. So what you derive the string during the derivation? So totally that is called as a sentential form. Means so I have to go for A derives alpha. Alpha is becomes a sentential form SF. SF nothing but a sentential form. So that is the idea of sentential form. Means if the sentential form of the input is scanned and replacement that can be done from left to right, it is called as leftmost derivation. Means here I am trying to expand the idea of the leftmost derivation, the third step. Similarly, the idea of the rightmost derivation that is given in the fourth part. If we scan and replace the input with the production rules from the direction is here reverse direction right to left, then it is known as the rightmost derivation. So from this you have to getting the basic idea of the derivation is you want to getting any string. For that obtaining of string process, you can make use of the steps. Means you can apply the productions various productions multiple steps. Entirely it is called as a derivation. Hence, the definition of the derivation follows like this is a derivation is basically a sequence of production of rules in order to get the input string. And what are types of generally we are recommending for the derivation? Leftmost derivation and also rightmost derivation. In the case of leftmost derivation, you are substituting a replacement of the string that can be done at the leftmost non-terminal. The direction you should follow the replacement of the string that can be from left to right. That is called as leftmost derivation. Another case is rightmost derivation. The replacement of the string that can be done at the rightmost of the string. So that is called as rightmost derivation. So after that, we have to see some examples for understanding of LMD, leftmost derivation, as well as rightmost derivation. We have to verify that some total for some three different production rules are given. The rule is first rule is 1, second is 2, third is 3. Means so what the corresponding grammar is? Suppose I want to write the corresponding grammar. First you describe the variables. What the variables are? Only for one single variable. E. So already I described in the last case. So what's the variable? What are the terminals? Terminals nothing but I think they don't have the derivation or simply some operators. And ID also consider the terminal because of ID do not have any derivation. Only capital E have the derivations. ID cannot have the derivation. And one more thing is set of productions. You write the total for 3 productions like this. Okay. And another is some maybe arithmetic operations asterisk symbol. This is another one. So one more is the identifier ID. Last one is the symbol is the capital E. So this is I think grammar for the corresponding question. But here I want to the string is ID plus ID into ID. What do you mean? You perform multiplication between the two values, addition. But what sequence generally will be in any other direction? First is the multiplication as per the precedence rules, as per the hierarchy of the rules. First you give the importance is the multiplication. So ID into ID. You done. And then you go for adding of ID. So first ID into ID. So which rule is suitable? I think the second rule is suitable. So you should start from the second production. Here applying the production is the second rule. A you can choose E becomes E plus E. So after that you want to obtain again plus symbol and ID. This is exactly you can make use of the first production means here E becomes E plus E. You can make a substitution in the place of E. You make a substitution is the entire string. Then it becomes E plus E into E. Means you are observing is here replacement of the string is at left side. Once again I will show the steps are very clearly. So the steps are like this. Here first I am taking the E plus E. Okay. Here what is the leftmost is the leftmost. Here you make the substitution. E becomes E plus E. Okay, as per this rule, this is the value into E. Here, total for 3 non-terminals are there. Here, what is the leftmost non-terminal is? The first E is the leftmost non-terminal. Because of the leftmost derivation, you should replacement that can be done at always leftmost non-terminal only. Here you should complete the ID plus E into E. Again after that is the terminal, it is not a non-terminal. Now we have only for 2 non-terminals, the first is the second. Here among these 2 non-terminals, what is the leftmost is? This is the leftmost. So you can get the ID is ID plus ID into E. After that we have only for one non-terminal, okay, this becomes the leftmost. Only for one is the leftmost non-terminal. So now totally becomes ID plus ID into ID. So here what happens is replacement is you are done at what non-terminal but leftmost non-terminal. At every step you are applying the substitution of the string or replacement of the string that can be done only at leftmost variable. So in this way finally you have to obtain the string is ID plus ID into ID. The given input string also like this. Means for the given input string, how can I choose that input string when you are applying the some sequence of production rules in the case of leftmost derivation? So this is the way for giving the answer. Okay. So now you make use of how many productions are, how many times you are applying the derivations, 1 time, 2nd time, 3rd time, 4th time, 5th time. You are taking the actions, multiple derivations. So finally, we can conclude that with the help of multiple derivation, you obtain the string is becomes like this. Why? Because of this asterisk is because I am taking the multiple derivations. So this is the example for understanding of leftmost derivation. So similarly, what the rightmost derivation is? You can verifying that this for the rightmost derivation. Means the concept is same. Means substituting the string or replacement of the string. That is the part of derivation. But where you apply this replacement of the string but at the rightmost variable only. Here E plus E. So what the rightmost is? This is the rightmost. So you can make a substitution with the alpha of production rule is already had the production is E implies E into E. You go for this substitution in the place of E. After that, again you are getting the total for 3 non-terminals. Again you have to go for, so what the rightmost is for the rightmost. Here you make the substitution using the rule is E implies ID. In the place of E, we make the substitution is ID. Again, among these two, okay, only for 2 non-terminals, what the rightmost is? This is the rightmost. Again, you make a substitution in the place of E is as a ID. At the end of the step, only for 1 non-terminal, so you make directly the substitution is ID. Here also you are getting the same answer. Means whatever your objection is, if input string is ID plus ID into ID, okay, to solve the question is using either leftmost derivation, that is previously we have discussed, or we are using rightmost derivation, we have to obtain the same input string. But applying the sequence of rules are maybe different. So finally, we have to getting the answer is ID plus ID into ID. So this is the example of rightmost derivation. And what do you mean of a sentential form? Simply say any production, it may be solve some strings or any string, your expected string. Suppose your expected string, it is not possible using a single step of derivation, you take multiple steps like this. Finally, you obtain the alpha. Alpha is some combination of terminals and non-terminals, but you can generalize, okay, because here I'm not taking a specific problem. So alpha nothing but some derived string. For example, previously I have discussed ID plus ID into ID, that is the derived string. That is you are taking the alpha. So here S implies alpha means S is derives what the string is alpha. Then this alpha is called as sentential form. Sentential form of S is called as sentential form of S. Is it right? Here also we obtain the same alpha, but alpha is obtained with alpha of many derivations. Finally, alpha is derived from the starting symbol is S. Here also you are taking the final string is obtained string is alpha becomes a sentential form of S form. Is also called as a sentential form of S. So that is you have to understand about the sentential form. Another topic is past tense. So what are the past tense? Past tense is very is similar to the derivation, but past tense is some kind of graphical representation. Like it is some kind of a non-linear data structure. What data structure exactly you are following is a tree structure. Tree is some kind of a graphical representation. And here you can separate the tokens, or you are attaching the tokens, you are attaching the characters or operators separately with the nodes of the tree. Past is also consisting of some root node, some intermediate nodes, and final nodes of the trees are called as ending nodes are called as leaf nodes. You can represent some any arithmetic expression or any input string with the help of some graphical representation of the structure of the derivation is called as a past tree. So hence I am defining like this. A past tree is a graphical representation of the derivation. Means already we have discussed only for 2 types of derivations, leftmost derivation as well as the rightmost derivation. So for every derivation, you must present one separate past tree. So for leftover derivation, we have defined one past tree. Rightmost derivation also you can define some other past tree. You are able to represent your leftmost derivation using some graphical kind of representation. Similarly, you can also present your rightmost derivation using some kind of graphical representation of the tree. This is called as a past tree. The start symbol of the derivation becomes always root node. Means in the given set of production rules, what is the starting production, where should you started, in that what is the starting symbol is, starting variable is. That becomes here root node of the first tree. For example, I am taking S implies A and S. Here starting symbol is S. It becomes root node. It becomes a root node. Means I am taking this as a root node. And with other some other intermediate or leaf nodes, maybe have S. So in this way, we can present some kind of parse tree for the derivation of S implies A and S. The definition is a parse tree is a graphical representation of a derivation that filters out the derivation in which productions are applied to replace the non-terminals. This is the idea of derivation, and we can present exactly like this. The leftmost derivation is already have obtained previously. For that, what the parse tree is. You check the first step is E implies E star. Yes, this is the starting symbol. Always becomes root node. Remaining nodes with total for 3 nodes. E star E. E into E. Further, you can expanding E becomes E plus E. Yes, E becomes E plus E. And next expansion is E becomes ID. Okay, E becomes ID. Next, this one is E becomes ID. E becomes ID. Next is last one is this also E becomes ID. This one no, E becomes ID. So it means what you followed the sequence of productions in the derivations, you follow the same sequence. As per that, you try to expand the tree from some intermediate levels to last level of a parse tree. Finally, how to getting this kind of parse tree with the help of what type of productions are leftmost derivations. If you are applying the rightmost derivation, then you are getting a different parse tree, but for obtaining of the same answer. So what the answer is? So finally, you are mixing all leaf nodes. I'm making the round. Okay, you can read it. You can read as ID plus ID, and this also no into ID. Of course, if you use the different derivation, we get the different parse trees, but obtaining the same kind of string. So this is a major idea of parse tree. So in your parse tree, the important points you are observing is all leaf nodes are terminals, is true, and all interior nodes or intermediate nodes are non-terminals. In order, travels gives optim original input string. Means we have the totally for 3 types of order: pre-order, in-order, post-order. But here applying what kind of order is in-order traversal, which gives the original input string. So this is the idea of parse tree. So we have some example for restating what the leftmost derivation for the string of this grammar, what the rightmost derivation for the string of the same grammar, and give a parse tree for the tree. See here I am showing the first one, the leftmost derivation. The string is not given. String is not given. We try to solve using LND. Suppose I am taking like this. Single step. So finally I am taking this step that I make a substitution. I don't want to continue. A star or A star. So means initially you can apply this prediction. This is the I think some string. Because string is here it is not given. Suppose any input string is given, the rules may be different. Finally you are trying the with the help of these set of rules, we are obtaining the corresponding string. You are able to show what are the leftmost derivation or the rightmost derivation and what the corresponding parse tree. In this way, we should solve the question of this grammar. Means here grammar is provided. Of course, here input string is not given. maybe you are assuming that some input string. For obtaining that input string, so you are applying what different production rules and what sequence for LMD and also for RMD, and you can represent both LMD and RMD in terms of graphical representation. That's the tree structure. You are getting the some different parses. Okay, so it is the idea. In today class, we referred the content of derivation parses from these references, and hoping that it is clear about regard to solve the LMD, RMD, and how you getting the equivalent parses. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.